viewers, welcome back to another session of your MOOCs course, which is Internet of Things, Design Concepts and Use Cases. Today we are going to discuss another practical experiment with Arduino board, and the title for today's experiment is Interfacing MQ7 sensor with the board. There are plenty of MQ series sensor. This particular series is famous for measuring variety of environmental gases. So, you can find many sensors such as MQ2, MQ5, MQ9, MQ121, MQ135. These are just few names that I can suggest. Today, we are just going to talk about MQ7 sensor, which is able to measure carbon monoxide gas available in your surrounding environment. So, in case in future if you are planning to work on any experiment which includes some environmental settings and you wish to measure some gases around you, this experiment is going to help you with your initial learning. In order to do this experiment, I am going to utilize one of the Arduino boards that we already know, and along with this we have your MQ7 sensor. On your MQ7 sensor we have 4 different pins. As you can see on screen, we have 5 volt, then we have a ground terminal, and along with this there is a digital output and one more analog output. So, if you go through the data sheet of this particular sensor, which will be available from respective manufacturers. So, when you see that, you will find this particular sensor can communicate through analog lines as well as on the digital line. So, respective to that, you can either connect it on the digital port of your Arduino or on the analog port of Arduino. So, as you can see on the pin itself, it will be written as D out or A out. So, if you are taking your signal from D out pin or D0 pin, then it will be connected to any of the digital pins available on your Arduino board. Similarly, if you are experimenting through analog output pin of your sensor, respectively it will be connected to the analog port of your Arduino board. So, as you can see here, I have shown a connection with 3 lines. One is your VCC 5 volt line, then we have ground, and other than this I have selected one A0 pin from my analog port. The same connection now we will be doing on the hardware side. In order to do that hardware based setting, I have obtained one Arduino board over here, and along with this I have gathered this MQ series sensor. So, with both these units, first I will create a initial interface in which we will be sending data to your serial monitor on the screen. But the next task, chances are that you want to install this particular sensor setup at some field environment to measure your environmental gases, that in this case will be carbon monoxide. So, it clearly means that you cannot put your laptop or computer on that field environment. So, in that case, how you can get your readings regularly at that field site? For this, you can have an extension with your LCD board. So, first task will be to create your direct interface with sensor, and then we will create a further interface with your LCD board, so that a complete setup for your field monitoring is ready. So, following the connection that we have on your screen, I am just connecting this sensor through these 3 wires. First of all, here on the sensor I have these connectors already connected over here, and along with this there is a potentiometer. This you generally may not require to set, but if you are doing some settings for your final outcomes and you do not find stability in your sensor readings, then chances are that you may need to adjust this potentiometer. Currently, I have taken a VCC terminal from here. Similarly, I have taken a ground terminal, and last one we have is your analog terminal. So, first of all, as we know, we have to connect the ground terminal. So, from your Arduino board, I am taking up one ground terminal right here. Next, we have this red wire to be connected into your 5 volt, which is at this particular slot. And after this, I have the analog data line to be connected on A0 terminal right here. So, this is your initial hardware connection with Arduino board and MQ7 sensor. Now, let us have an idea about the code that you need for this particular interface. For this, I will be switching to your software terminal that we already know will be your Arduino IDE. For this, first of all, I am opening an initial program in which you can see the setup part. Now, important thing over here is this particular sensor does not require you to have any kind of library, because this is a very basic sensor that can work without any special library. So, you can see I have not installed or included any library in the software side. So, first of all, on the setup side, I have initialized my serial monitor with a baud rate of 115200. Next to this, since this is a environmental setting related experiment that makes up your project of repeated inputs that you may like to get from the field environment, and for that we definitely need a continuous sampling, and for this I have added a loop sequence over here with a specific delay of 5 seconds. So, what we have done simply, first of all, I have initialized a variable sensor value in which I am reading my analog data from A0 pin of your sensor connection. Next to this, I am printing this particular string, that is CO reading, on your serial monitor, and next to this I will be adding sensor value that I have obtained from the analog pin, and after this we have a small delay of 5 seconds, which definitely you can control as per the required sampling setting. So, this is all about your code, and now we are ready to interface this particular code with the hardware. As you know, the first thing we need to do is to connect this USB port with your USB terminal over here, and you can see your Arduino has turned on, and similarly your sensor has also turned on. This LED shows the status of your sensor, and now we are ready to send our code. For this, first of all we need to compile your code, and at the same time we can see if our port is connected well or not. So, we can see here COM8 is connected and our compilation process is also done. Now, I can hit on your upload button. It will recompile your sketch, and after this it will be uploaded through your COM port to Arduino board. And as you can see, the uploading process is also done. And as I have already told you, we are going to get your sensor output on the serial monitor now. So, let me open the serial monitor for you again. So, from this terminal I can open it. We have the right baud rate here, and now you can see the sensor readings on your screen. So, because I have added a delay of 5 seconds only, so you can see a continuous sequence of readings over here. Depending upon what settings you have in that particular field environment, what type of gas values may be available in that case, you can see the outputs over here. There is one important thing that you need to know while making selection of your sensor. As you can see on your screen, this particular sensor can measure gases from range 10 to 500 ppm. It completely depends upon what are your field settings. According to that only you have to select your sensor, because this particular works within this particular range. If you need a wider range or a different range depending upon your environment, which is target for your application, you can choose some other type of gas sensors as well. So, currently we are done with the first level of interfacing. Now, as you told that you have to sometime install this particular setting in the field environment. For that, you definitely need a connection with this LCD board. So, we have already done that experiment, and you know that we just need to enhance connection with the 4 lines of your LCD board. So, let me take you back to this I2C board, and we can insert these wires again in your Arduino. Before making connection, as you know, we have to take off the power supply, and again we are picking up the ground terminal from here, inserting it in the ground terminal available on your board. Next to this, we have your VCC terminal, which I am inserting over here on your 5 volt available on this board. But there is one more condition. Many Arduino boards have only single 5 volt terminal available on them. In my case, I have 2 5 volt terminals over here. In case if your board has single terminal, you may need one additional thing, that is a breadboard, so that you can extend one 5 volt connection from here to this board, and then from here you can extend it further to this chip as well as to your sensor. Currently, since I have both 5 volts available on the chip, so I can eliminate this breadboard part, but you always need to make sure that this connection is available on your board. After this, the next line I have to connect is your SDA line, and I hope you remember from the previous experiment that this particular pin we need to connect on A4 terminal, and after this we have SCL line, we can connect it on A5 terminal. So, this is your entire sequence of codes available, and next we can update our coding sequence to this board. So, in order to update this sequence, what additions you have to make on the software side? Because the previous code that we have seen, the output in this particular code was only on the serial monitor, but now we have to send information to the LCD board as well. So, definitely there will be some extension on your software side as well. Let me display you both sides of the story. First of all, on one side I will be opening the previous code that we have already discussed. So, on the half of the screen you will have this, and on the other half of the screen I will be sharing another set of code, so that you can have a comparison between sequences. So, first of all, in the previous code we have directly the setup part, but now as I am adding your LCD board into sequence, so I may need to update your library for liquid crystal I2C, and along with that the address and type of I2C information. So, these 2 lines are added into your new code. Next to this, in the setup part, here also we had the serial begin, and here also you will find serial begin. But along with that, we have all your LCD initialization and initial setting codes that we have discussed in your LCD part already. Including this now, next we have the loop part of the previous code. So, the same loop part first of all we will be including here. So, you can see both these part will stay same, because they are just to send your data on the serial monitor. But now there is an extension in your new code. Here we are updating readings on LCD board, and for which first I have set my cursor on 0 0 position of your LCD board to display this particular string which defines the parameter that I am going to read from the environment, and next to this I am displaying my sensor value, and I have added a delay of 10 milliseconds to take next reading from the field environment on this LCD board. So, this is your entire sequence of updated code, and now we can have only this one on the screen, and we are ready to send this particular to your hardware board. First of all, I will be checking terminal connections, which are definitely correct here, and now we can upload our code. So, it will first compile your sketch and then the code will be uploaded on the hardware side. So, it is uploading and soon we can see output on your serial monitor as well as on the hardware. So, here first of all on the hardware you can find the readings right here. So, this is the current measurement of carbon monoxide gas from this particular environment where I am recording this entire session, and at the same time we can move to the serial monitor where we can see the same set of readings from the environment. So, it means now we have one input device which is your this MQ7 sensor, and we have two output sides. One is your software side with serial monitor and other is your hardware side with LCD board. So, this is your another experiment where we have taken readings from the environment and we have gathered data based on the carbon monoxide settings. We will meet again in another video with different set of sensors and different experiments. Thank you very much for this particular video.